Welcome to this explainer. Today, we're going to completely flip how you think about SQL. We're moving way beyond just treating it like some basic syntax test. Instead, we're going to peek under the hood and really understand the database execution engine. So, if you've ever felt like, you absolutely have the coding chops, but somehow still freeze up in those high-pressure technical rounds, you are exactly in the right place. Okay, let's just dive right in.
Let's kick things off with kind of a wild question. Why is it that database veterans, people who literally optimize enterprise systems for breakfast, why do they get rejection emails after writing syntactically perfect code on a whiteboard? Because trust me, it happens every single day. You stroll into a senior interview, get what looks like a super simple SQL question, you type it out flawlessly, and you fail. So what gives?
Well, here's our game plan for today. We'll look at why senior developers actually fail, run through a 4-step thinking protocol, map out the true logical execution order, figure out how to escape the dreaded null trap, and finally master some really advanced calculations.
All right, part 1, why senior developers fail.
The secret is officially out. Modern interviewers, they honestly don't care if you've perfectly memorized every single obscure line of syntax. What they are actually testing is your logic. They want to see your business problem-solving framework in action. Senior candidates usually fail simply because they jump straight to the keyboard. They start typing before they even understand the data layout, the constraints, or those sneaky hidden edge cases.
And we have to address the elephant in the room here, the cloud myth. There's this huge misconception that you need to be a Snowflake or BigQuery guru to pass modern interviews. But here's the counterintuitive reality. Cloud environments actually mask bad code. They just throw massive, incredibly expensive compute power at inefficient queries. Don't fall for it. If your background is in older on-premise systems like SQL Server or PostgreSQL, that is your superpower. Your grasp of B-tree indexes, execution plans, and real under-the-hood optimization makes you a vastly superior cloud developer. Because guess what? The core engine logic is exactly the same.
Moving on to part 2, the 4-step thinking protocol. By literally just forcing yourself to follow these 4 steps, you will instantly pull ahead of the pack. Step 1. Deconstruct the business question. Translate their vague prompt into strict technical constraints. Step 2. Check your schema and granularity. Ask yourself, what does one single row in this table actually represent? Step 3 is identifying edge cases. This is where 90% of people crash and burn. Ask your clarifying questions out loud, like, hey, can this ID be null? And Step 4. Map the logical order of execution. Visualize how the engine will actually read your instructions.
Which brings us right to part 3, the logical execution order.
Here's the kicker. SQL does not execute top to bottom. We humans read and write it that way, sure, but the engine flows through a strict mathematical sequence. It grabs the raw data in the from phase first, then it links everything up in the join phase. Only after that does it filter rows in the where clause, bundle them in memory with group by, filter those specific groups with having, and then, way down the line, it projects your columns in the select phase before finally sorting it all with order by. If you want to pass the senior round, internalizing this flow is absolutely non-negotiable.
Okay, part 4, escaping the null trap. Let's test that framework with a seemingly innocent request. Find the names of all employees who did not make any sales in the year 2025. Now, a junior candidate hears this and immediately starts hammering out a subquery. But this tiny little prompt is hiding a massive logical pitfall that destroys experienced candidates all the time. The entire trap hinges on something called 3-valued logic. See, in SQL, comparisons aren't just true or false. They can actually evaluate to unknown. This rears its ugly head when the engine hits a nullable foreign key. Like, imagine an anonymous walk-in sale where the system just recorded the employee ID as null.
This is exactly where the gap between junior and senior becomes glaringly obvious. The junior coder types out a not-in subquery, runs it, and boom, 0 rows returned. Completely blank. But the senior developer, they spot the potential for a null value in the sales data right away, so they use a not-exist clause instead. Why? Because not exists forces strict true or false Boolean logic, completely bypassing that null trap and safely pulling the exact right records.
Let's break down the math on why that not in query completely fails. When the engine processes not in, it turns it into a long chain of and statements. It asks, is the employee ID not equal to 1? True. Not equal to 2?
True, not equal to null? Hold up, stop right there. In SQL, evaluating anything against the null is instantly unknown. And because it's an AND chain, a single unknown mathematically nukes the entire equation. True and unknown equals unknown. The whole where clause collapses for every single row. That's why thinking like the engine saves your interview. Finally, Part 5, Mastering Advanced Calculations.
Let's tackle a classic whiteboard problem that truly tests senior-level syntax. The prompt is, write a query to calculate the 3-month rolling total revenue for the company for each active month. So, before writing anything, we define what a rolling total actually is in this context. The requirement states the output has to include the current month's revenue plus the combined revenue of the previous 2 months.
To pull off this specific rolling sum, we absolutely have to use a window function. Think of window functions as operations that let you do math across a specific set of rows, but without squishing them all into a single row like a standard group I does. It lets us peek back at the previous month's data while keeping our current month's row perfectly intact.
Picture yourself sitting right in front of a standard SQL Server interface. You're typing out your select statement, and right inside your sum function, you open up an over clause. You order that window chronologically by the month, and then you drop in the magic syntax, rows between to preceding and current row. That right there tells the engine the exact size of your rolling window.
When the database engine runs this, the logic is pretty beautiful. For March, it automatically scoops up January, February, and March and sums them up. Then, when it moves down to calculate April, the window literally slides down. It drops January off the back and sums up February, March, and April. You've just elegantly solved a genuinely complex business request without writing some horrible, convoluted self-join.
But wait, let's tie this all the way back to our logical order of execution. Remember how we said the engine processes where clauses way before it even looks at the select phase? Well, window functions are calculated during the select phase. So if your interviewer throws a curveball and says, okay, now filter this to only show months where that rolling total was over $1 million, you cannot just slap that into your initial where clause. It'll fail. You have to wrap that window function in a common table expression to respect the engine's strict order of operations.
I'm going to leave you with one final, pretty provocative architectural question, the kind you should be asking in your next interview. Let's say you're writing a query, and you notice an employee has active paychecks in the compensation ledger, but their ID doesn't even exist in the master employee directory. That is a massive data integrity failure. Pausing to point that out and asking your interviewer, hey, should I trust the master directory here or derive our active list from the ledger? That proves you aren't just a code monkey. It proves you think like a principal engineer who deeply cares about referential integrity. Start looking at SQL as a complete system of logic, not just commands to memorize. Thanks so much for hanging out with me for this explainer, and I really hope this completely transforms how you attack your next technical round.